So let's go take a look at MindTap problem 3.6. I thought I lowered the light in here. It's still kind of bright on here. This one is about calculating the value of pi. And there's a formula to calculate pi. I'm sure there's more than one formula. I know that a common test of supercomputers is to calculate pi to the 7th trillionth decimal place or whatever. But the formula is not that bad. However, I feel like at least giving pseudocode to do it together. And what pseudocode is just a programming language that's not really a programming language. It's just a description of the algorithm, of the logic. So let's go take a look at it. I mean, we could actually just do it together. That'd be even easier. But the German mathematician Gottfried Leibniz, I have no idea how to speak German, developed the following method to approximate the value of pi. Oh, look, there's the answer. Quick, don't look. Well, too late. There. All you have to do is watch the video, go and freeze frame on that second, and you get the answer. Anyways, here's the formula. If you look at it, pi over 4 is equal to 1 minus 1 over 3 plus 1 over 5 minus 1 over 7 plus ... just means that it's going to keep continuing. Right, so this is after 4 iterations. 1, 2, 3, 4. If we had a 5th iteration, it'd be plus 1 over 9. 6 would be minus 1 over 11. The next one would be plus 1 over 13, and so on. Oh, why don't we just code it since it's in the video? Anyways. So write a program that lets the user specify the number of iterations. If they choose 1, it just stops there, right? Only pi is equal to, once you finally get your answer, you're going to multiply it by 4. Because it says pi divided by 4 is equal to whatever, so just by math, you have to multiply it by 4 to get the right answer. So 1 iteration would get you 4. The next iteration would be 4 times whatever that is. The next iteration would be 4 times whatever that is. The next would be 4 times whatever that is, and so on. So we got to ask them, enter the number of iterations, and then our loop's going to run as many times as they specify. And the approximation of pi is that. So let's print our input message out here. We've been doing input messages, in a couple of different ways. One is ask for the string and then do the conversion. The other is to use the int right on the same line. I'm going to show you a third way, which is to make it even a little slightly bit more fail-safe because it lets them type in 4.0 and not have it crash. But we'd still need to have to convert it into an int because we're going to use a for loop. And a for loop only works with an int in the range, not with a double. So I'm just going to copy this statement. But here's what our new and improved way of getting this input is going to look like. What am I going to call this? Iters, I, max. If I do max, it's going to light up in a different color because it's a keyword. I don't want to do that. End, number of iterations. How about end? End is equal to int, parentheses in parentheses, and inside those parentheses, let's do float, parentheses in parentheses. And inside those parentheses, let's do input, parentheses in parentheses. You can see where this is going. And then two quotes, and in there we're going to paste our message that we copied from over there. So why did we do the input float int? Because if they type in 4.0 or something like that, we're going to convert it to a float first, and it's not going to crash based on the fact that they entered a decimal point. But then once we get that float, then we can round it off to make it a whole number. This just stops it from crashing if somebody enters 4.0 rather than 4. All right, now we need a while loop. We're going to need a counter. Counter equals 1. Why did I pick 1? Because the first time you add 1, the next time you subtract 1 over 3, we can kind of see a pattern here, right? Because 1 is the same thing as 1 over 1. It's still too bright up here. This is the same as 1 over 3. That's the same as 1 over 5. So it's going to be like 1 over 1, 1 over 3, 1 over 5, 1 over 7. You can see that that's definitely a pattern. And the pattern is that if we wanted to do 2 iterations, what's our upper number? Our upper number is
3. What do you mean by upper
2
number?
plus 1, 2 minus 1. Yeah, 2 times 2 minus 1. That's kind of making sense. And then 5 is 3 iterations, so that'd be 2 times 3 minus 1. And 7 would be 2 times 4 minus 1. So let's make our range statement look kind of like that. And since range goes 1 past anyways, we're not going to have to do that minus 1 business anyways. But we do need something to hold the value of pi. How about pi? That's a good word for it. Got to initialize it before our loop. So for x in range, parentheses, we're starting at 1, right? 1 over 1, 1 over 3, 1 over 5, 1 over 7. And we're going to go up to 2 times the end. Right? If they type in that they want 6 iterations, we're going to count up to but not including 12. But we're not going to go up by 1 each time. We're going to go up by 2 each time. Right? We're going to start at 1, and then we're going to go to 3, and then we're going to go to 5, and we're going to go to 7, and so on. So we're going to increment x by 2 each time, not just 1. One more trick, and this is the real trick. How do you get it to toggle from subtracting to adding each time? That's the trick. And so what I'm going to do is I'm going to set up a variable that equals positive 1, but then it's going to flip to be negative 1 the next time. And then it's going to be positive 1 again, and so on. And it's going to keep flipping like that. And there's a couple of ways you could do that. But one way is just to multiply it by negative 1, right? Because 1 times negative 1 is negative 1. And then the next time you multiply it by negative 1, it becomes positive again, and it keeps flipping. So we're going to need a variable to contain that value. It's just going to flip between positive and negative 1. So there's our for loop. Let's calculate what we're adding to pi each time. So add equals 1 over x, right? Whatever x. X starts at 1, so it's going to be 1 over 1. Then the next time it's going to be 1 over 3, because we're adding 2 to x each time. So 1, 3, 5, and so on. So it's equal to 1 over x times the multiplier. So it'll be either a positive or a negative 1 each time. We need to then modify the multiplier so it'll flip from being positive to negative and vice versa. So mult equals mult times negative 1. Of course, there's a shorter way of writing that. Mult start equals negative 1 would do it. So this is just flip the multiplier. Flip it negative, flip it to the opposite. And this is what we're going to add to pi. I don't even know what to call it. The comment to add. What we will modify pi with. And the third step is to actually add that to pi. Although if it's a negative number, right, we'll subtract it, but that's cool. Pi plus equals add. And if it so happens that add is negative, so much the better, it subtracts from it. And just for debugging purposes, why don't we print out x and the add and pi, right? So we can watch it. Then we'll delete this line or comment it out or something. So print parentheses x, comma, add, comma, pi. So we can watch the values change. Now that's the end of it. That's the end of our loop. So I'm going to put end 4 there in a comment. And lastly, we're going to print their little message here. They had a message they wanted us to print. The approximation of pi is. So after the end 4, completely unindented, we're going to print this message. Print parentheses quote. The approximation of pi is space end quote. No space even. Is end quote comma pi in parentheses. Hopefully that's exactly what they want. Not sure why that's underlined. Maybe it'll go away when I run it. All right, enter the number of iterations. What do they show it as? They show it with 5, and that's the answer they get. So let's find out if that works. Oh, what did I do wrong? The equation is pi over 4, and I didn't include the over 4 part, so I just have to multiply my final answer by 4. So after the end 4 statement, before the print statement, pi times equals 4, just to take care of this part. And this is a classic programming problem. I've been thinking about assigning it to some of my classes, but I don't want it to be part of MindTap's series of problems, so I don't mind giving you the answer. Run it again. Five iterations. Do my eyes deceive me? Is that the exact same answer? What did I do wrong? Oh, it's commented out. That's real useful, right? There. Once more with feeling. 5 iterations. 3.39. Now, if you've got a couple of digits of pi memorized, 3.14159, we can see that's not real close, but it only iterated 5 times. What if we ran it and made it go 50 times? It's a lot closer, 3.12. What if we ran it and made it go 1,000 times? 3.131, whatever. It's still not 3.14159, but it's getting closer. One version of the assignment that I've given in the distant past is to make it run until it gets within a certain percentage of the actual value of pi, and then tell you how many times it had to run. All right, so that seems to be the code, but I better test it. And so run it one more time, look at the output, and then I'm going to remove that print statement. And then run the tests. So 5, here's what it's doing. X counts from 1 to 2 times whatever they typed in. So it's going to count 1, 3, 5, 7, and 9. And we see that 1, 3, 5, 7, and 9. The first time it added 1. The second time it subtracted 1/3. You see that negative 0.333. The third time it added 1/5. 1 over 5 is 0.2. The fourth time it subtracted 1 over 7, and I guess I'm going to trust that that's 1 over 7. The fifth time it added 1 over 9, and then it's all done. Multiply the answer by 4 and we're good to go. Let's see if the tester likes it. So if I come over here, click on the tasks and run the checks. And it worked. If you get an error message and you can't quite figure out what's wrong, click on this thing and it'll say 4 out of 4 checks passed, or 1 out of checks passed, or nothing. If you scroll down, you can see the test cases. The first time it tested it just for 1. This next time it tested it for 5, which is what we were doing, and then 10 and 999. So if only one of your tests works, you're going to want to come in and look at the test cases and see why it didn't work for 5 or 10 or 999 or whatever. Alrighty. So by my recollection, we're done with Chapter 3. I hope so, because I want to get on to the new stuff. But we better confirm that. Yeah, those are real lame printouts. Blank pages. I'm impressed. Alright, I haven't been doing this too much recently, where I said I was going to put everything inside a main method. Well, let's go ahead and do that even before we start our lecture, just as a matter of course. So I'm going to go and create our lecture file. Looks like we're on Lecture J. So DEF space main parentheses in parentheses colon. I'm just going to stick a print message here, print Lecture J, right, just to have something here, end quote in parentheses. And then down here I'm going to have an if statement that calls main. And you don't really have to have this, but it's better programming to do it. And anytime I say double underscore, I mean that. And so there's actually going to be like 8 underscores in the message that I type here. So if, no parentheses, if double underscore name double underscore equals equals, double equals, quote, double underscore, main, in double underscore, end quote, colon, and then under the tabbed code, main, parentheses, in parentheses. Now what this does, and I've talked about this a little bit, is it makes it so that if this code was imported into another file, it wouldn't automatically run at all. Because it's lame programming to have your code do a whole bunch of stuff just because it was imported, right? You'd be really annoyed if as soon as you did import math, it started spitting out a bunch of stuff. I better test it to make sure it works. Run module. Did I say Lecture J? Alright, so that's cool. Now let's go get our PowerPoint. Please tell me we're done with 3. Oh, how about that? You're not going to save my spot? Oh, I saw it. Not done with 3. But we're close to the end. I can tell we're close to the end. So, the break statement. The break statement exits a loop. You can exit a loop early if you want. Let's give an example of that. Just because the while loop or the for loop is counting from 1 to 100 or something like that, you can break early. So up here, underneath the print statement, don't unindent. Everything needs to be indented, because if I start unindenting, it's no longer part of the main method, the main function. So let's just make a counter that counts like from 1 to 10. For x in range, parentheses 1, and I want it to go to 10, so I'm going to make this say 11. Count up by 1 each time, so 1, 11, 1, colon. And if you recall, you don't have to put that comma 1 there. It assumes 1 if you leave that off. So this is going to count from 1 to 10. Let's just print it out. And let's let it rip. Make sure it works before we add the next thing. Okay, cool. But what if for some reason, I don't know why, but for some reason when we hit 6, we decided we're tired of counting. If x equals 6 colon, and you don't need to put all those spaces there, right? then break. If x equals 6 colon, on the next line, print parentheses quote, that's it, I'm done. Exclamation mark, end quote, end parentheses, and then break. And when it runs, it's only going to print 1, 2, 3, 4, 5, 6 now, because the break statement kicks it out. Oh, I made a mistake. Does anybody who's real familiar with for loops recognize my mistake? Yeah, this is not indented. It needed to be indented inside the for loop, and that's why putting comments like this, end for, a real good idea, because that made it clear that this is in the wrong place. So I need to cut that, paste it, and tab it over, not necessarily in that order. If you want to tab a whole bunch of lines at once, and you're using idle, which not all y'all are, but even if you're using another editor, this probably works. You can highlight all 3 of those lines and hit the tab key. Or you highlight all the lines and hit format indent. And then these need to be cut to go inside the for loop, tabbed appropriately. The if statement needs to be lined up with the print statement, and then these things need to be lined up inside it. Now we're good to go. Right, so it counted 1 to 6. It was supposed to count from 1 to 10, but the break statement kicked it out early. That's what break is for. In this case, it's silly. If I wanted to stop it at 6, I should just change the for loop here. But you can make indefinite loops that break when the user wants to quit that way. For example, we could be asking the user for a series of numbers to add up. So let's make a variable called total and set it to 0. This needs to be lined up with the for in the print statement, not totally unindented, not against the margin. And I'm going to do something that's going to look a little bit strange. It's just going to say while true with a capital T. What that means is just loop forever. It would be an infinite loop, except we are going to have a break statement in here. So then we're going to ask for a value. Score equals int, parentheses, input, parentheses. I kind of like the workspace editor, right, in MindTap, except for its alarming tendency to crash. I'm going to close my parentheses right on the spot, just to help, and then inside the quotes, inside the parentheses, I'm going to put my double quotes, and inside there I'm going to put my message. Enter score or -1 to quit. Space, space, greater than. And then I'm going to check, is the score equal to -1? If it is, I'm going to break. If score equals -1, colon, break. So this needs to be tabbed equal to the score, right? Because this stuff needs to be inside the while loop too. This is part of the body of the while loop. So if I'd unindented it like I accidentally did this if statement, it wouldn't work. This stops it from being an infinite loop, even though while true makes it look like it's going to be an infinite loop. Because, well, the condition's true, it's going to loop forever. No, it's not, because we're going to get tired of running, we're going to type in -1 and it's going to break. Now I'm going to put my end while comment here. So here's our code so far. Let's run it and see if it actually works. I haven't actually tested, well, I tested the first part. All right, so enter score. All right, 100. Enter score, 200, 300, whatever. -1 to quit. Now it's out. And I didn't print the total or anything like that. I could do that after the while statement, right? Make sure it's lined up exactly. Print, parentheses, quote, total equals, end quote, comma, total. Now it does something right after it gets those numbers. 1, 2, 3, -1. Whoa, what have I done wrong? I don't know. Oh, I'm an idiot. I left something out. Anybody spot it? I declare total and I set it equal to 0 here. Where does it change? Nowhere does it change, and that's the bug. So I'm going to put an else in here, or maybe not even an else. It doesn't really even need an else. But why not? Else colon total plus equals score. Maybe you see why I say it doesn't even need the else. You don't have to make this change that I'm just about to make because I'm going to undo it. But if it was like this, you know, break kicks it out of the loop, and if it doesn't break, it's going to do that, right? It'll do that even without the else word. But it kind of looks nice, maybe, to have the else keyword there. Now to work. I hope. 1, 2, 3, 4, -1. The total was 10. Yeah, that's true because 1 plus 2 plus 3 plus 4 is in fact 10. You can use this method to do what other languages would call a do loop. Python only implements pretest loops. A pretest loop is where the loop is at the top and then the body is underneath it. A do loop is where, Python doesn't even have them, where you have all the code and then you have the condition. So it has to run the code no matter what, and then the condition is checked. Well, if you feel like you have to have a do loop for whatever reason, that's called a post-test loop. You can just do while true, and then you can put your if condition at the bottom and break out. And it simulates a do loop, even though the language doesn't have it. No problem, you can do it. Get lost. So the break statement exits the loop. Well, what if you don't want to exit the loop? What if you want to repeat the loop early, before the rest of the stuff? And I'll show you what I mean. I'm going to come down here. We're going to demonstrate another keyword called continue. For x in range 1, million. Well, don't worry, we're not going to run that many times. In parentheses, in colon. We're going to print out x. Oh, that was to demonstrate break. I certainly don't want to run to 1,000,000 if that's the case. So I'm going to change this back to 111, just like the other loop. 1, 11. Print x, and then we're going to check something. If x is equal to 5, colon, we are going to so-called continue. What does that mean? It means repeat the loop immediately. Don't do the rest of the body. So underneath that if x statement, but tabbed to line up with the if, not to continue, print parentheses quote, gonna do it again, end quote, in parentheses, print parentheses quote, just you wait, end quote, in parentheses. That's really about enough, huh? Input parentheses quote, hit enter, end quote, in parentheses. We're going to wind up taking that out because that's a bit much for what we're trying to demonstrate. I don't want us to have to keep hitting enter, but just to prove the point this first time, watch what it does. All right, I'm tired of entering scores already. I'm just going to put a -1 there. It printed out a 1. Going to do it again. Just you wait. Hit enter. 2. Going to do it again. Hit enter. 3. Going to do it again. Hit enter. 4. Going to do it again. Hit enter. Don't worry. It's going to do something a little bit different this time. 5. Notice it did not do the going to do it again. Just you wait. Hit enter before it jumped to 6. Right? It behaved differently. The reason why is because we had this here. If x equals 5, continue. And continue means go back to the top of the loop. right? Go again, even without doing the rest of the stuff. And that's why it did not ask me to hit enter between 5 and 6. I'm going to remove that statement now, or at least comment it out. All right. Enter score, -1 to quit, -1. There. See, it counted from 1 to 10, but it did not print the same messages between 5 and 6 that it did between every other number. Why? Because as soon as it hit 5, it did that continue, which stopped it from printing gonna do it again, just you wait. Why did it stop it? Because they were after the continue statement. All right, we've got a bunch of code here that maybe we don't want to have to hit enter, and type in data every time. I'm actually going to uncomment that out, but I'm going to do something a little bit different now. I'm going to back tab all the way against the left margin and define a new function. def main2 parentheses in parentheses colon. And down here inside our if statement that runs stuff, I'm going to comment out the call to main and make a call to main2 instead. Now we have all that code, but we're not going to call it anymore, right? We're not going to call the stuff that's asking us to add to the score and the gonna do it again, just you wait, right? Nothing calls main, so it never jumps up here and does this stuff. Instead, any extra code that we add is going to be inside main2 instead. And if we wanted it to do both of them, great. We could uncomment it and it would do all the stuff in main, and then it would repeat the stuff, it would execute the stuff that's in main2. So you could use continue to do some error checking, and if they type in something stupid, then you can continue immediately, like this. Let's do that inner score business again. Total equals 0. While true, colon. This asks for the score. Score equals int, parentheses in parentheses. Inside those things go the print parentheses in parentheses. Inside those parentheses goes our message, 2 double quotes, and inside the double quotes goes our message. Enter score between 0 and 10, comma, or -1 to quit. Getting to be kind of a long message. I'm going to take out the spaces here. I'm going to put a greater than sign here to let them know where to type it. There. Let's get our score. Now we have our score. But we gave them some rules. It was supposed to be between 0 and 10, or -1, and if it's not, it's invalid. So if score less than -1, or score greater than 10, colon, print parentheses quote, invalid input, end quote in parentheses. Continue. Why continue? Because they gave us bad data. We don't want to do anything. Now let's check to see if they wanted to quit. If score equals -1, that was their message that they signed that they wanted to quit. Print parentheses quote, okay. Done with adding scores, end quote in parentheses, and then break. And if neither one of those conditions is true, we have good data because we verified that it's not less than -1 and that it's not greater than 10. So it's good data. We can add that to our total. Total plus equals score. So we're ruling out the bad values early, right? Here's a bad value. If it's greater than 10, we just want to continue. And yes, we could have gotten away with not doing the continue if we had arranged everything inside of else's and stuff like that, but it's just to demonstrate the point. This is a common technique, actually, especially when you have more than one error condition, right? If there's 7 things that may go wrong, it may be nice to just have a whole bunch of if statements up at the top, and they all continue, and then you have your exit condition, which might be a break, and then the rest of the code. There could be, 50 lines of code after that, but you've ruled out all the error conditions early. All right, now that we've got our new score, let's print it out. So I'm going to back tab so that it's underneath the while. I'm going to put end while there, and then I'm going to print out the total. Print parentheses, quote, total of scores equals, end quote, comma, total, in parentheses. And let's run it. Ooh, look at that. Wonder what I did wrong. Int argument must be a string. Oh, that was moronic. Anybody spot the error here?
You put print?
Yeah, why did I put a print here? We want them to input. So go change that print to an input. And by the way, if you didn't catch me do it, make sure that if you started a new function here, you went and commented out main and made a call to main2 instead. All right, so enter a score. If I type in something bad, like -11, invalid input, it printed that message out and it immediately continued, so it didn't do the rest of the stuff in the loop. And then I type in 2, and then maybe I'm done, right? So -1 to quit. The total of scores was 2. Random numbers. Random numbers are fun. Random numbers let us create dice games and things like that. Haven't we already done random numbers? Is that a yes?
I think so.
Like maybe we did a guessing game with them or something?
Yeah, we did that. The guessing game assignment.
Okay.
In the Minecraft.
All right. Well, why don't we play with random numbers in here? I don't think it's going to take long. Why don't we define yet another main so that we don't have to do this score input? So come down here, back tab completely, def main3, parentheses in parentheses colon, and then you can comment out that call to main2 and put in a call to main3 instead. All right, we want to generate some random numbers. If you've ever played Dungeons and Dragons or a game like that, you're used to the idea that you create your characters by rolling 3 dice for each attribute. So your strength is, 3 dice, and then your intelligence is 3 dice. Maybe we'll do something like that. But firstly, we got to prove that we know how to generate a random number at all. What's a random number? It's just a number you can't predict ahead of time, right? Like rolling dice, unless you're psychic or something. So we need to import the random function. The slide may say from random import something. Let's go take a look at how they did it exactly. Nope, they just did a plain import random. That's my preferred way. And how many dice are we going to roll? How about we just roll 3 dice or 10 dice, or I don't care. For x in range, parentheses 10 in parentheses colon. Let's get a random number, so I'm just going to call it r. R equals, all lowercase, random, dot, next, no, dot, rand int parentheses, starting with 1 and ending at 6. Now this isn't like the range statement where if you put a 6 there, it only goes 1 to 5. I made this different, and it actually goes from 1 to 6. And let's print it out. Print, parentheses, quote, random number equals, end quote, comma, R, in parentheses. And that's going to print out 10 random numbers. End 4. And there it went. It generated 10 numbers between 1 and 6. Well, you may be familiar with the idea that in Dungeons & Dragons and Pathfinder and games like that, you have all sorts of weird dice, not just six-siders, not just like Yahtzee or poker dice or craps or whatever. You've got things like okay, that one's a bit extreme. That's a 100-sided die. No, it's not. That's a golf ball. You can't fool me. All right, like this, right? 20-sided dice or 12-sided dice or 4-sided dice, whatever. So if we feel like making numbers between 1 and 20, we can do that just as the same, right? R equals random dot randint 1 comma 20. That's a random number between 1 and 20. Print. Random number equals, end quote, comma, R, in parentheses. Now we could write a little function that adds 3 random numbers together and returns the result. Because if we're playing one of those games where you roll 3 dice and add them together to get a strength or something like that, it'd be neat if we could do this. str equals roll 3 parentheses in parentheses. Wouldn't that be nice? And then if it did all the work, so we didn't have to write for loops and call random int and stuff like that. Well, this isn't going to work. Oh, and by the way, apparently str is a bad variable name because it lit it up in purple. How about DEX for dexterity? Your character's got high dexterity. So here we're going to come up, and above DEF main, we're going to write a new function called roll3. DEF roll3 parentheses in parentheses colon. We're going to again have to import random, unless we went up to the very top of the code and unindented it. Import random. And there's always more than one way to do something, but we could do this. R equals 0, R plus equals, and let's do it the right way, not about the way I'm about to do it with a random, let's do it with a loop. R equals 0 for I in range, parentheses 3, in parentheses, and each time we go, we're going to add a roll to it, a new random number. R plus equals, no spaces between them, random dot next int, parentheses 1 comma 6, in parentheses. And then back tab one level, but not all the way against the margin, return R. And let's describe what this is doing. Roll 3 dice and return the sum. That's what this is supposed to be doing. Roll 3 regular dice, right? The cubes, since that's a 6. Okay. So there we have. We've made a dex with a roll of and other attributes. Your character's intelligence, oh, that's a bad one too. Your character's constitution, how many hits you can take, is equal to roll 3, right? How about just ST for strength? ST is equal to roll 3, parentheses, in parentheses. IN for intelligence. Oh, that's not going to work. Okay, forget intelligence.
What about IQ?
Pardon me?
IQ.
IQ, awesome. IQ equals roll 3, parentheses, in parentheses. Now that's enough. Let's print out our character. Print parentheses, character stats, end quote, in parentheses. Print parentheses, quote, strength equals, end quote, comma, ST, in parentheses. Print parentheses, quote, constitution equals, end quote, comma. Oh, I don't need that space there, do I? Don't need one here either. End quote, comma, CON, in parentheses. Print parentheses, quote, dexterity equals, end quote, comma, DEX, in parentheses. And one last one for intelligence. Print parentheses, quote, intelligence equals, end quote, comma, IQ, in parentheses. So I've gotten the code so big that it won't all fit on one page down here at the bottom, but close. Looks like I added one too many character stats, or if I took some spaces out, that would work. Or if I took out this end for. But I like the end for, so I'm going to take that space out. Now it will all fit on one page. Nope. Alrighty. So anyways, let's run it. Let's run it and see if it works. And then I'll wander around. Oh, and it doesn't. It's not next INT. I'm sorry, I'm thinking of another programming language. What did we say it was? We have a good example of it just in the main3 function. Instead of random.nextInt, it's supposed to be...
Is your random supposed to be capitalized?
No, but it needs to be... Or am I wrong? Am I wrong? But anyways, I think it's supposed to be RANDINT right there. And I did see a capital R, you're right. It popped up momentarily with a capital R, but there we go. And so there's our character stats. He's not too strong, but he sure can take a lot of hits. Now it does seem to be fitting all on one page. Why was I convinced it wasn't? Anybody need typos or extra typing time? Just a second. Let me come around. So one problem you can have is putting code inside a loop that shouldn't be in a loop. And if all of this stuff was indented, including the end for maybe, it's inside the for loop, so it's going to repeat it 10 times. So when it runs, right, sure does print a lot of characters. Maybe I want to roll up 10 characters. Maybe that was cool, but that's not really originally what we had. So I'm going to undo that. That's why I strongly recommend at the end of your loops you go ahead and put a comment there, so it makes it blatantly obvious that the rest of it should be unintended. So they have a guessing game here. Can we do a guessing game in 7 minutes? Sure we can, because we're awesome. Let's go ahead and do this. We're going to implement one more main, right? So back tab all the way, DEF main 4, parentheses in parentheses colon. Comment out this one, the call to main 3, and instead make it main a call to main 4, parentheses in parentheses. The way a guessing game works, didn't we do this? Or I mean, I do the same thing in another class, and maybe I forgot. where we generate a secret number and we ask for it? Okay, so import space random, and let's get a random number for them to guess. Secret is equal to random.randint parentheses 1 comma 100, right? That's common. I'm thinking of a number between 1 and 100. Now let's tell them that. Print parentheses quote, I am thinking of a number between 1 and 100, end quote, in parentheses, semicolon. Let's declare a variable called guess, and let's set it something that's not possible, right? So that we can then have a while loop. What do I mean by not possible? It's not going to be between 1 and 100, so I'm just going to start it at 0. So while guess not equal, exclamation mark equal, secret, colon, because they haven't guessed it, let's ask them for it. Guess equals int parentheses in parentheses, and inside those goes input parentheses in parentheses, quote, take a guess, space space greater than sign, end quote. And make sure that those two closing parentheses wound up there. Now let's see if they got it right. If guess is less than the secret number, they guess too low. So if guess less than secret, and this is all still tabbed underneath the while, if guess less than secret, we're going to say print parentheses quote, sorry, too low, exclamation mark, end quote, end parentheses. What's the other choice? Well, what if they guess too high? If guess greater than secret, colon, print parentheses quote, sorry, comma, too high, exclamation mark, in parentheses, or end quote, in parentheses. Otherwise, they got it just right. Tell you what, let's make that an elif, because it can't be both too low and too high, right? All right, I'm going to back tab one level so that we're under the while now. That's the end of the while. Let's check to see if they got it right. Now really, the way the code is worded right now, we don't have to do this check because there's no way to get to this point without it being right. But one of your changes, this is going to be the homework assignment, needs to rely on the idea that if you make too many mistakes, it breaks out of the loop, and in that case, the guess might not be right. So if guess equals secret, colon, print parentheses quote, congrats, exclamation mark, you got it, exclamation mark, end, exclamation, end quote, in parentheses. Else, colon, print, sorry, better luck next time, period, end quote, in parentheses. How about an end if here, just to mark the end of that code. Now it could be that I got it without any typos. Never know. I'm thinking of a number between 1 and 100. Take a guess. 50. Sorry, too high. 25. Still too high. 12. Okay. I'm just going to keep playing until I get it right. Your number is going to be different. I'm going to finally get annoyed and just start counting down, right? Eventually I'll get it. Yeah, it was 13. if you do that business where you start at 50 and then you go to 25, you know, and you keep chopping it in half each time, that's called a binary surge. Okay, I want to make one more change to it, and then I'm going to mention the homework. What would make this game more fun? Well, for one thing, if we knew how many guesses we had made, right? And the other thing might be if it quit, right, after a certain number of incorrect guesses. So let's declare something called mistakes. Mistakes equals 0. And underneath here, watch everybody just for a moment, because I'm inserting, we always get in trouble when I start putting code in places where it wasn't before. You see where this elif is and where this one is? If the guess was less than secret, let's add 1 to mistakes. So mistakes plus equals 1. Right there. Do the same thing under the elif. Elif, wait, no, why am I doing that? No retyping. Mistakes plus equals 1.
Well, see you later. Take care.
All right. One last thing down here. Else colon, lined up with elif, print, parentheses, quote, you've made, end quote, comma, or how about mistakes so far equals, end quote, comma, mistakes, in parentheses. Now I'm going to back tab again and do my end if. So what did I just add? I added that line. I added this line, and I just added the else statement and the line underneath it. So those 4 lines are the new stuff. And if you're getting behind, that's okay. I'll print it out for you guys in class, and the code will be uploaded for those of you working at home. All right, I need to start guessing again. 50. Sorry, too high. Okay, dadgummit. I put this in the wrong place. I wish I hadn't made the mistake. Get rid of that else. Delete that else and back tab print so that it's lined up with the if and the elif. And that puts the end if in the wrong place. So I'm just going to delete that. I'm really sorry about that. I'll wander around and help y'all right now. Print needs to be lined up with if and elif. You know, we could move the print statement to above the input. Do that. Cut the print statement, the mistake so far, and paste it above the guess equals input. That's the best place for it. So I just moved it there. Let's make sure it works. Take a guess. 50. I've made a mistake. It was too low. 75. I made another mistake. 90. Okay, fine. 96. What? 99. All right, between there's 2. 98, 97. Got it. So I made 5 mistakes. If you play a perfect game, you can always get it within 7 guesses. And I'm not going to go into the logic and how you would calculate that. Just accept it on faith right now that you can always get a number between 1 and 107 guesses, and there's a mathematical formula for it. All right, the homework. Don't worry, I will wander around and help y'all. The homework. Take our guessing game and add 2 features to it. One, don't let them enter data below 1 or above 100. You can use continue like we did in our lecture. to help. Don't have to. There's always more than one way to do things. And 2, make the game stop if mistakes gets to 10. And there's more than one way to do that as well. You might use a break, like we did in lecture. Alrighty, I need to come help y'all. I'm going to pause the recording. I should make a Dropbox for those of y'all who did catch up. Let me do that. Alright, it's there. So if you did get it right, you can go ahead and upload it. If you didn't, no problem. I'll help you now. If you need a printout of it, I can give you one.
Can you just scroll to the bottom?
Sure.
See the-
I hid the homework from you.
Yeah. Thanks.
Can you print that out for me?
I sure will.